Hello everyone, welcome to another stream. How's it going? Yes, it's been a bit of a crazy past few days for me, really. Been lots of things going on. So, yeah, it's not really been smooth my end, but if anyone asks questions, I'll happily go over what's been going on, but until then, we'll just crack on. So, oh, for crying out loud. I didn't have my laptop charger plugged into the wall, so now my laptop's just shut down. Right. So today's stream, we're going to be trying to get the Voxel model, the new Voxel model file format finished. Basically, I got it worked on a little bit off stream, and I've managed to finish what was doing last stream. So last stream was trying to get the test map rendering again, which is basically just a sine wave, right? And then each y-axis will give you a new material. So basically, I got a material palette system in the engine, which just allows you to make material palettes, save them out to a custom file format, and it also saves that PNG file. So in Magic of Voxel, when you start trying to do some models and stuff, it can get basically the colors you're trying to use and has the same one as in engine and in the editor, in the Magic of Voxel editor, which would be cool. And this is what we're trying to get working next. Right, so we're just getting the sharp. Cool. There we go, up and running. Cool. Yeah, so we have had in the past Magic of Voxel import and working. It's just we've now got a new way of rendering the voxels, right? It used to just be like literally a 3D model, sorry, a 3D volume of blocks, but now we have a tree of blocks, so a 4x4x4 tree. So, here's the settings. We can go into here and look for like voxel. Sorry, we can do wireframe. And so as you see, we draw the back faces of the volume around the around the voxels, and we basically ray trace. We do a ray verse box, and then we ray trace from the out in. Or if you're inside the, where the camera sits inside the box as well. That's why we render back faces, so you can go inside the box and it still works fine, right? Ta-da! So, yeah, we're going to get the outlines working as well off stream. So the shading code renders outlines around each voxel to give it a bit of a look. Hang on a minute. Yeah, so we've got these nice little outlines. I'm not sure if I'll keep them, but it just helps distinguish each block a bit more. So, we look at the debug hits. We hover over the mouse, you can see that it goes through some kind of tree, right? We zoom out with the camera a bit. There's like it's a 4x4x4 tree basically. It goes through. We should probably draw the boxes in screen space so they stay a fixed size rather than feel like it's horrible. They're very thick at the bottom because it's not in screen space. That's something to improve for later on. Yeah, we should manually project the lines of the thing into screen space or something, maybe, but then you don't get Z. No, we'll have to do something in the pixel shader, I think. Yeah, something like that. Anyways, things to work out later on. But yeah, so it's cool. So now, because we changed the format of the voxel models, now the import from Magical Voxel is broken. So we're basically working on, wait a minute, so we close these. We can just leave this running in the background, leave that there or something. Go something there. Yeah, any questions, feel free to ask away. This is the old format. So as I said, it just used to be a 3D volume of, used to have these things called voxel model slices. And a slice is just like a 3D slice of a, I've renamed it to a keyframe, but it used to have like, you know, um, to try and save space and save memory, it used to try and do stuff that was clever. Like if you have a volume of a certain size, but the model doesn't fill the whole volume, it would basically have an inner volume that it would only store the voxels for and kind of offset it when it rendered it. But now we're doing it as a tree, we kind of automatically get those savings anyway, because only when, we only have voxels at allocated in a certain area. Sorry, we only have nodes allocated in a certain area when there's voxels there. So when there isn't voxels there, we don't allocate any nodes. So I've just left out that sort of stuff now. So this is the old one. So the new one's a tree now. So voxel model. So this is what the new file format is like. So a lot of this will look familiar because we basically had this at runtime anyway. So I've just moved it into a different file called voxel model rather than voxel shared. And this is still shared between the CPU and GPU. It's just now it gets saved out to a file, so it's versioned as well. It's got file and GPU. So we've got some flags, like if the animation loops or not. So there's one file per animation is the way I've done it for now. So that means if you make anything in the Magic of Voxel, the importer that we've got only works when there's one model in the scene and it has animations. And that's just the way it's done for now. Maybe we can make it do more, but it's just the simplest thing to implement for now. So you've got this sort of material index dim to say how many bits you need per voxel to store the material index. So you got one model and it basically has a start of keyframes. That's only at runtime only, we need that. And so a number of keyframes, maximum timeline, that frame index, sorry, the maximum timeline number, and the flags. Now the keyframes are basically just a set of distinct models, 3D volumes, that will basically get flipped through like a flip animation, but in 3D. So these just have a root node. And you can imagine it just pointing to a volume like one of these, right? Each with their own distinct set of voxels. And then each node basically looks like this. We've got a node hot array and a node cold array. If you were to do something a little bit more simple, you just have a node structure, but we've separated into hot data and cold data. So the hot data is what you access like all the time. And then the cold data you only access when you actually hit any of these children indices. You'll look at the cold data and find where the children are, basically, right? And we've also got some model hashes as well. So this is something we had in the old system, which I'm bringing forward into the new one. And that is your keyframes, right? Imagine if you have a character animation and you've got your many different animations. You've got like a run, a walk, and all of this, right? Some of your models might be exactly the same across different files, right? So the way we're going to solve that is by basically having a hash per keyframe, and there'll be a hash table sitting in the game, and it'll basically just go, right, does the hash exist? If it does, we'll reuse the currently loaded one. If it doesn't, then will load it in, right? So this saves us on loading times and also memory. And also if you happen to have two things running at the same time, and you're rendering them in that, there'll be less stuff evicted from the cache, hopefully. So this stuff like that you can get some savings on, so that's pretty cool. Yeah, so now we've got this thing called a voxel model file. This is the new thing. It stores one model, which is basically an animation. Maybe we should call it animation, but anyway, it's a model. How many nodes are in the file? How many keyframes? How many voxel material indice words? And then obviously just all the data that we just need to extract out. So I've got most of the way through getting this data written out. It's just pretty close. So we go to the Vox builder. So when you use Magical Voxel, I'm sure you've all seen it. You save out those Vox files, right? So I've got a thing called, here we go. There's these sort of Vox files or whatever, and basically you can, edit them and then you save them out and you get this sort of VOX file thing. This Vox builder, so we save them in currently assets, voxel models, and I've just got box.vox and this sort of shrinking box animation. And it's just a custom file format that Magical Voxel made up, and it's quite easy to read. It's basically like a riff file format, if you've heard of it. I never heard about it before this, but it's apparently quite old. And essentially it's just a tree of chunks. And so you just recursively make a parse chunk thing. So each chunk can have child chunks, and a chunk can have as many chunks as children as it wants, right? So yeah, I've had to change this a little bit where, so the data it's basically extracting is a bunch of keyframes that's just found loose in the file. And then we basically are looking for one kind of like shape node, I think it's called. And the shape node tells you is basically a model or is like a set of keyframes which make an animation. And if we're only looking for one of those in the file, and if it has two, it's a thing we error on because we don't support that. But we can always support it in the future, right? So we just have a bunch of global keyframes that we basically fill up. We find a size. It also will be preceded by an X, Y, Z, and I, which this basically means the voxel data. The size just tells you, hey, we've got a new global keyframe coming in. So we basically just set up that by, just adding one on, just in a bump allocate and set it up. Then the next chunk it will find in the set of children would be a XYZW, and this is just all the voxel data. So we parse over all the voxel data and find the maximum material index. This gives us how many bits we need per voxel. And then we initialize the keyframe this time with how much bits it wants per voxel and the width, height, and depth of the keyframe. Now we spin over the voxel data again. We spin over it again, and this time we do this voxel set. So this API is the same API we're using in the game to generate this map procedurally, right? Again, very simple function. It's literally just sine wave in, a sine wave basically. But what's cool is you can literally just like call voxel set and it's going to build the tree automatically, and you can do like, remove voxels and all that, and it sorts everything out. That's very, very useful. So we can use it for the builder program and for the game when it's at runtime and we want to procedurally generate voxel instances, basically different voxel models, right? Which is super powerful. So I'm even like considering very soon, like as soon as we get a basic map, we can even do like procedural like plant life, basically like grass and plants, all with this system, which would be quite cool, like trees and stuff. So yeah, it'd be very, very powerful. So yeah, afterwards we basically, you know, keep track here whether we've already came across. So we hash the whole tree, right? And then we look at the hash table and say, hey, has this hash already existed? Um, if it's a new one, we'll jot it down and be like, right, this is the first time I've come across this thing. And then if not, and if it's something we've already come across, we basically take the root node index and we get rid of, we just store the. I don't think we should do that here anymore because I've actually sorted that out later on. Yeah, we'll basically jot down this is the first time we've come across it, but later on we basically put the root node index over and overwrite it. But yeah, we'll get to that. So this is that shape node we was just talking to you about, where it basically just says, right, I've got a new animation, and we only support one of these. So we've found it already. Multiple models inside a single Vox file not supported at the moment. So yeah, so this is what basically makes this array here of model keyframes, and it just fetches them from the global keyframes, which we just ran over, right? So there's two arrays, global keyframes and a single model. And then at the end, there's some extra stuff like meta where it talks about like the timeline, frame min and frame max and all this. But after we've parsed all the chunks, we basically just go over and trim the beginning and trim the end off that go outside the timeline, min and max. And then we simply just try and throw it out to the file system. So we've got to traverse over the tree. Oh, wait a minute. Yeah, this traverses over all the keyframes and counts everything. We should probably do a bit of a check in here. Hang on a minute. Do. Yes, so this spins over and basically gets some stats. And the stats basically say, right, how many nodes does this keyframe use? How many nodes are actually allocated, because we pad our allocations out so they align to cache lines, right? And how many voxel entity words are being used as well. So we accumulate these stats, and this helps us figure out what's the maximum size of the file that we need to allocate inside the program and other things. This here is saying so we can say skip duplicate, skip duplicate matching. Oh, skip duplicate keyframes. Oh, keyframe, there we go. So the keyframe's already been counted, right, with the exact same data. Just skip it basically. And yes, we count all that up. Cool. Start a binary writer. Start the file, this new voxel model file. We sort of set up the model. Is there anything else to do with the model in there that's going on? Frame, that's it really, and frame max. Well, we didn't set the frames count. So keyframe count set and that'll be G model keyframes count. Cool, I'm glad we didn't miss that one. And we're trying to like, yes, we did this sort of allocate the VLA. So the encoder system supports arrays which are not fixed size, right? So they're of variable length, and you can sort of say which field they're from, basically. And it produces these lovely little macros where you can tell it the size you want them to be, and it will set the field up as well. So that's pretty cool. So it does allocates these arrays by basically bump allocating into the file. So we, using this writer here, so it's bump allocates. And then we've got this save function, which I've got to double check works, but we basically set up this sort of keyframe save, and it's going to go over the keyframe tree, like node tree, and essentially copy it into a linear array, and also get rid of all the alignment stuff where it's not going to try and align it out to a cache line because there's not really much point doing that. It's going to conserve memory because it's going out to disk, and it's going to like bump allocate it all sequentially basically. So we go over all the keyframes, and if it's, this is a duplicate keyframe, just reuse the data, right? So it just points to the, oh, this is a good point. KF. You've got to make sure this matching index gets you the global index, but it doesn't get you the local one. So we map to C confined. Yeah. So we should probably rename this to like global. And then probably call it local. Sorry. Yeah, that's definitely way better. So these are global. Excuse me. Yeah, so we need to probably take this code and as we're bumping these on, wait, do we care? I don't think we care about the global one, we just care about the model. This global one can probably go away. It's only when we make them into a model keyframes. So that would be, you want the hash, just this. Yeah. Right, that's better. Right, so now it's the proper index we actually want. Yep. So rather look into the global keyframes, wants to look into the model keyframes, so the local ones, and use that index and get the root node and basically reuse. So those root nodes would have already been put out to the file in a previous iteration, right? In a previous iteration of this for loop and called the save function. We're just basically pointing to the same data. So that offers some savings there, which is pretty cool. Obviously, you don't get savings across files, even though there would be some. But yeah, spitting out, I guess a better way of doing it could be just to make it, making a bunch of, one file per keyframe. But then you would basically want to sort of pack those into a single big file for release, So one file per animation is good enough for now. We can mess around with it later on, right? When we want to actually optimize it, when we know what the problems are. But yeah, if we want like maximum savings on disk, we should probably split it out into one file per keyframe and then pack them all together somehow later on. But yeah. So yeah, we've got to look at this save function again because I think I'm halfway through writing it. But then after we've done that, we just basically copy the keyframes over into the file as well by allocating them into bump allocating them into the file, and then bump allocate the keyframe hashes, and then end the writer, and then write it all out to the place where the build tool has been requested to write it. So yeah, that's basically it. It's quite a small program, which is great. It's only like 500 lines, so quite all right. A lot of the complicated stuff is in our Voxel module, which is shared between the game side code, the render code, and also now this Voxel model builder thing. So pretty cool. Yeah, so let's hop over to the save function and get it sorted out. And then we can try and get it running again. We'll have to write a load function which does it the other way around, right? Which loads from the file and takes the data which is allocated and packed tightly, and then spread it out across. Just keep allocating it again, basically. But yeah, I did kind of forget to pray, so let's do that right now. Father in heaven, we thank you, Lord, for this day. We bless your holy name. Thank you, Lord, for being our great provider, and thank you for looking after us in all the ways that you have, all the ways we do know, and all the ways we do not know. Lord, we just pray for your mercy and forgiveness for all those times where we've sinned against you, all those times where we've fallen short, all those times where we've transgressed the law. And Lord, I just pray that you help us, perfect us in every way, and help take us to new heights. Lead us, Lord, into those paths of righteousness for your name's sake, and help us be more like your Son, Jesus Christ. And Lord, I just pray for each and every one of my viewers. If they don't know you, Lord, I pray that you lead them to you. Put the right people in their lives, and take the wrong people out of their lives. And I just pray ultimately that they receive the blood payment that Jesus Christ has paid for their sins in full. And it's only by that precious blood that anyone can enter into heaven, their sins can be forgiven of. I pray each and every one of them gets to understand the gospel and put their faith in Jesus Christ and his payment rather than trying to work their way to heaven of which they cannot obtain. And accept that the only one who is perfect is you, Lord God. Thank you, Lord. In Jesus' name we pray. Amen. Cool. Yeah, so this save function is recursive. It's pretty cool. So we just start off at the keyframe, which is the root node. We bump allocate. We just got basically this save thing is just, it's got an array of nodes, words. It's got sort of some capacities of how many are in these arrays and a cursor along there. So all we're doing is just bumping it and taking a tree which is all over the place in memory, but each of the siblings are aligned to cache lines and stuff like this. So when you start reading from one, you get the rest of them in memory. It's quite good. So we're taking that sort of cache line efficient data and sort of packing it down into a file so it's more size efficient. So we start off at the root node, we sort of just bump that and call this node save. It's got destination slot and there's a source, and then pass in the save context again, basically. So I was doing it where it returned a value, but I was looking at it and I was like, it's not the way to go. So cool. So when you start off, it basically just does the copy over. So it reads them at the Voxel cache model port and gets the pointers to them and just copies them into the destination slot. Now here's the half written code, but it's nearly there. But effectively it's just recursive descent, right? It goes over all the children, and if they're not a leaf node, it tries to save those out effectively, but we've still got to write that fully too. So let's carry on. So if it's not a leaf node, get the children count. We bump allocate all of the sibling nodes, all the children basically. Together in one go and store it here. So this is when it's not a leaf. So leaf means that it's got the voxels right there, right at the bottom, basically. So if it's not a leaf, it's obviously just another 4x4x4 set of children. So we get the bit set, just do a least set bit removal type thing, loop. So it traverses the bits which are set. And again, if it's not a leaf, we get the packs child offset based on the child index. And you wanna, this is your DST. So that'll be a source. Source children start index. I guess this could just be called DST children start index. So source, DST, DST. Yeah. So yeah, just recurse. So that's the most hot path of the file, basically, when it's not a leaf node, because there's many. I think so. No, maybe not. It's the hot path at the beginning, right, when it's going from the root down, but at the bottom it might touch more of the leaf node code. But anywho, so yeah, if it's a leaf, then how do we handle that? So we're trying to copy the. I don't think you do anything here. Nope. But what you do is you basically bump allocate the number of words that you need. So we don't have that data here. How do we traditionally handle that? In these guys, we have an index dim that gets passed down as well. So plop that there. And so an index dim basically is saying how many bits, how many words, I forget what it is now. It's a number that basically represents how many bits or words that you need per voxel for a material index, right? How big is your material index? So we need that to know how many words that we allocate here. So I just need to find that. There's the stats and the stats. Oh no, it doesn't bother passing it down because it just tells you how many words you need. Or not words, how many. Yes, so we find the key frame. That. Cool. So what does this do? So get the index dim. I don't know, maybe we could call it, yeah, how many words? So that material index words count, I think that's what we actually want passed down. It's a bit easier to work with. So yeah, we'll just do that outside of the root function basically. So yeah, we'll bump allocate these guys. So rather than nodes cursor, it's going to be the voxel material indice cursor. So we just bump. And we should just be able to copy them all in one go as well. Just got to get there. So the children count would just be this material indice words count. Cool, so now we just do a copy. So that would be a core mem copy element many. So it's basically a mem copy except for it does type multiply by size of the deref of the pointer, that sort of thing. So you've got save voxel material indice words, and it's the DST start index. Yep. Now the source. The source should be stored in the cold auxiliary. Oh, we've already fetched it out. Lovely. Lovely. So we just need to find. I think that's it. And then you just put the words count in there. Should be it. Yeah, so those ones don't really get packed down any more than they already are, whereas the nodes do because the nodes are padded out. I didn't really want to start messing around with the voxel indice data because it's so small already, kind of. You know, because say if in a 4x4x4 root node, if like the hang on a minute, why is this one so bad? This debug is not that good. We've got to fix this in a bit. Is it really bad? Yes, it's kind of alright. It's just the final, yeah, you can see, right? This final one is so small and it's not a 4x4x4. It's actually it's a level off. It's doing it per voxel rather than, yeah, we've got to sort that out in the debug. But yeah, so imagine the final 4x4x4, so it's 4 voxels by 4x4. If it's got empty voxels, it still has space allocated for those. I didn't bother doing ultra packed voxel data because you have to reshuffle it around and all this, but we could do that if we want to. The maximum size is No, I didn't. Yeah, the reason why I didn't do it is because um, for y- for for the map, it uses 2 bytes per voxel, and so that ends up being 32 bytes of memory. So is that right? No, 32 U32s. That's what I meant to say. In total for 4x4x4, which is 2 cache lines, right? So that's like the biggest bytes per voxel. Sorry, biggest bits per voxel that you would need. And it's only using 2 cache lines worth of data. So it's not really, it's going to be, it'll be too much sort of extra code to sort of work and have problems with, I think. It's just easier we just fix allocate the voxel data. Because you'd have to have a lot of nodes which have half of the 4x4x4 allocated. Maybe we do for it to be worth it, but for now, it's alright. But yeah, a lot of like, I imagine a lot of the files that we export from, like, the ones which are on the map, which come from the program where you sort of actually, you know, this program, yeah, third party Magic of Voxel. When you model them in here, the color palette I only can go up to like at most like 8 bits per voxel, but we can definitely do smaller. And so that's already going to just be at most 1 cache line anyway. So you can't sort of have your voxel data cache aligned and still leverage and still make it smaller if stuff isn't there. So I don't think it's worth it. Anywho, yeah, so what else gets done? I think this is basically the code written out now, the save function. So that would be cool. I'm happy with that. Right, so now we've just got to call it properly. So we just got to find data. Go to the stats one, I reckon. All right, so we need to work out this here. So how many words per leaf node basically for the material data? Work that out. There. Plop that here. And voila. Right, so I think that is the voxel builder now done. Nice. So I know what we can do next. So maybe we can try and get it compiling, and then we'll do the load function, which does it the other way around, basically. And then hopefully we can get something working. This is a different repo. Hopefully this mostly is compiles. Static is a reserved keyword. Oh, wow. Why is this complaining then? Voxel model generate.h. So it's obviously trying to chuck it through the shader compiler, you know, these horrible things we have to live with. Yeah, so basically I've made it such that yeah, so I've removed a restriction where I can now get ENC files, which is this custom encoder format that I have, where it wants to be used for a file and on GPU, I've just lifted the restriction now for that, where you can do both at the same time. But the thing that we have to do is comment out stuff that you don't want to use on GPU. So this type info stuff, I thought I had an if-def around here anyway. Yeah, all the type info shouldn't be available on GPU. Wait, let's check that doc file. I think I've written about the type information, to be honest. No, I've not really written about the type info in the docs. Ta-da! Okay. Right, so I think it's just always there anyway. I don't know why it never showed up. Oh no, type info is only there if file is enabled. Ah, that's what it is. Yeah, so if we go into the encoder code gen, we'll just find that basically. So hmm, where's the type info at then? If file has versioning. Ah, there's a if def glsl. Alright. Well, let's have a look at this some more. Right, we didn't do it all the way apparently. Just gotta find where this ends. Just code gen code, you know, it's not always the best. Always looks a bit weird, but there you go. This is the way. Right, so that ought to be good enough. So if we run that now, it should if def that out on GPU. And the answer is no. Oh wait, I've got to tell the system that we've changed the code gen. So I've got to save this file, and then the build systems depends on it, and it will say like, oh, you want to use the new version of the encoder codegen to build, to regenerate all your codegen files. Because if not, if we make changes to the codegen and even the asset builders, it will just start rebuilding absolutely everything. So we want to kind of limit it to any particular file that we save again. So if we check in, we've got to update the version number. So on other machines, it would happen that same way too. So if I just save it, the timestamp will change and it should trigger a full regen there. So I think something else happened here. Right, we'll relook at the file again to see where the statics are. But let's see if we made a difference. I think we did. Here it is, let's reload. When we reload, we discover... Come on. This is a bit long. The answer is no. If def... Oh, it's already got it commented out. Yeah, this is great. We're gonna write so far. Yeah, why are we commenting out this file again? That's a recent development. Oh, because it's got It's got an array which is a variable length. That's why it's doing it. That's cool. Right, so oh, these guys are not getting it for some reason. Why is that? They're called version 0 type info, but I thought we did that. Version blah type info, exactly. The way you know work. Did we not save the file? No. Let's up it to 1. And then let's also save that one again, just in case. Definitely rebuilding a lot, so what's going on? You know what, is there two places in the code base where it does it? So version whatever type info. Is this like the source? Yeah, I see it here, you see it? But then it's got that there. Yeah, they've all got them there. These if-def GLSLs, so... Right, what can I do to sort this out? I might do what any good person would do. Delete the build folder. Yeah, I'll fix that bug. The dependencies are slightly the wrong way around, so it doesn't always... Oh, it's still not triggering. Wait a minute. Let's reload this file. There's an if-def GLSL right there. Right, so what line is it now? 301. Oh, this is awesome. Right, okay. Cool. Oh, it's got these static inlines. Right, so these when we do like, when we're trying to... So for the voxel model file, those sort of functions that we generate for it to like access the variable length arrays, that needs to be if-def'd out. Right, so maybe it was doing it, but we just didn't see the line. It was generated, we just weren't seeing the lines. Hey there, J Full Stack. Welcome, sir. How you doing? God bless you. How are you? So that would be your VLA, more VLA thingies. Where's the VLAs? Alloc VLA, these guys. Pointer. What else are these things? What are these? Packed. Oh, we need these guys. Right, so this, the pointer. Yeah, so the VLA and the pointer. Because files can have pointers in them as well. And that's basically just like a relative index thing. These both need no shader allowed. Basically. And voila. It's going to be a lot of them, but it'll solve the problem. Right, so we just need to change the build timestamp. And off we go. Come on. No. $301. We're not in the right place. Thank you so much, Norris EXE. God bless you, sir. How you doing? Welcome to stream. How do I become a better Christian? Well, there's the things to do, right? There's, make sure you pray every day. We should ideally pray when we wake up and go to sleep, pray to God. Worship, get a good playlist on your phone. Worship music. That really, and ideally before you pray as well, you should always, if you can fit it in, worship as well. Get yourself in the zone. You really feel the presence of the Holy Spirit more when you worship God, basically. And spend time in your Bible as well. So ideally, you should probably read your Bible every day. Lately I've been kind of slacking on that, to be honest. I need to get back. I have like a whole bunch of notes on my phone, right? Where I it's just my wife just messaged me. Just check on something. BRB. Sorry, I was just checking on my son. My wife was just asking to check how he is temperature wise. Get a fan in there if not, but it's good. But yeah, what was I saying? So yeah, on my phone I have like notes, and when I find a good Bible verse, I'll chuck it in there and try and basically go over it to try and keep it in my head and remember it basically, so I can always recall it. Because whilst you're praying, if you can have Bible verses at your disposal, it's a good one. What's another one? Yeah, find a topic that you want to learn more about in the Bible and research it. Have fun, like and really get in there deep with it, because it leads all over the place. It really helps you understand your Bible more, where stuff is. There's so many good deep things in the Bible you can read and understand. Amazing. And how do we pray? I pray like on my knees when I start out. Do you pray aloud? Yeah, pray on your knees if you can. If you that's what I typically do. Sometimes I would just be praying while walking. It really just depends on how you're doing it. But ideally, when you're praying before bed and when you wake up, should be on your knees really. But if it's like prayers during the day, obviously walking around is probably all right. What's other ones? Struggle praying out loud. Yeah, you should try and pray out loud. Like unless obviously someone's sleeping, you don't want to wake him up. God can he understands your thoughts, right? He's tired of sinning. Yeah, I see what you mean. Yeah, so here's some advice. Like, if you're sinning a lot and struggling, committing the same sins, right? You obviously got fasting and prayer. That's a good one to do. Do it for like once a week. Once a week, pick a day and do a fast where you don't eat until like tea time, basically. So skip breakfast, lunch, basically. And try and you know don't eat after dinner the previous day, right? Anyway, um, and pray for that whole time. But another one as well is if you're struggling with sinning. Um, I think there's a verse in Romans 7 where is it Romans 7 where Paul is talking about like before I knew the law, I did not. It's not like he said he did not sin or something like that. It was talking about more of like the fact that the law says I should not covet, right? I shouldn't be envious, I shouldn't be jealous, right? Um, I didn't really do it. It's kind of saying it like that, right? But now the law says I shouldn't do this. My body wants to do it. You know, it's a bit like saying like someone says, "Don't touch that thing." You're like, "Oh, I want to touch that thing." Or someone says, you know, don't look over there. Your body wants to look over there, right? You know, don't. Um, there's something that tempts you into breaking the law, basically, right? Um, so when you have this idea of like, hey, uh like when you focus so much on like falling short and breaking the law, I think it's in Romans 7, right? I think it's the course where it's like, yeah. Anyway, it's a good read somewhere in here. Uh, Basically, put your focus rather than on like failure and breaking the law. Right? Obviously, when you do it, just like apologize and pray, like, sorry, Lord. Your focus should instead be on Jesus, right? And if you read God's word every day and pray and keep seeking God, you know, just keep reading his word, like especially the gospels and things like this, right? In the New Testament. Keep understanding, learning more about Jesus and who God is, right? Keep doing that. And these sins will just drop off you, basically, right? Because it's the Holy Spirit that works these things out of you. And it's not by your own strength, right? It's you're sort of surrendering to God, surrendering to Jesus. Put your mind, focus on Jesus and learning things of the, you know, walking in the ways of the Spirit. And these things just drop off, right? That's where your focus should be, is Jesus and not the sin, right? And the sin will go away. Yeah. But this is stuff, you know, I'm not perfect too, right? This is stuff I'm still learning. I'm just able to tell you because it's stuff I'm also going through too. But yeah, just that's the focus, right? Um, but yeah, life is hard. Oh. No worries, sir. All right, where was we? Oh yeah, we had a problem still. Yes, so encoder code gen. What was going on with this thing? Yes, these VLA thingies. We're not. We saved it. So alloc VLA. We got more of them, have we? There's another one. No, generate array. Maybe. No, this is not it. No, this is actually using it. Hmm. Right, I don't know if my system is actually right. So delete the build folder again. Right, I think my thing isn't picking up changes or whatever. They're all doing it properly, but anywho. Right, Voxel shared. Why are you complaining now? You're not even part of the system. Oh yeah, it's not part of code gen, right? So if not def. Right, here we go. Right, it's not part of the code gen anymore. This is cool. 78. What are you complaining about? Identifier. What did you expect? Yeah, what did you... Inline is a thing, right? It's core. Yeah, core shared is included because that will include core shared, right? Da-da. So oh, okay, so this, oh, for crying out loud, we've got to do a define because type def is a reserved keyword but not a thing because they can supposedly just implement it and instead. GLSL. To be honest, all shading program languages, you know, suck. But we have to live with these things. Right, 66. Oh, run out loud. So it's because effectively we've done this versioning thing. So we're using files now instead of just put it in GPU. So it has to prepend like a version number before it. So I'm trying to get around it by kind of type defing it, but now I use define. So now I've done some macros and it just, the whole thing's blown up. So sometimes there's enough macro stuff going on where it puts v0 in there and sometimes it doesn't and it's just all blown up. So was it in shader? No, it's in shared. So we define these things. So that would already get rid of the buffer type. Sorry, the define, that would already so GLSL. Can I put that into a separate window? I don't want that. You know, I do use AI. I use it a bit, right? I don't, but I don't. I use it when I want an advanced Google search. That's what I use AI for. You know, I don't want to be rolling the slot machine while I'm just trying to get some code going and not liking it and trying to express to a machine what I want. That's cool. Yeah. Orthodox or something like that. Been thinking of joining the community. You know, to be honest, I just go to, you know, my wife got me into, you know, Christianity. It took me a while. So I go to Pentecostal. And to be honest, the doctrine is quite, you know, it's difficult, right? When you hear people say, "Oh, they're part of this one or that one," you know, or they're a Catholic or an Orthodox or whatever, right? When you look at that, the belief of that branch is one thing, but what each individual member actually adheres to is different. So, yeah, I just try and stick to what's in my Bible as much as possible. And yeah, But where I go to, the doctrine is quite sound actually. I think it's initially I was like, oh, maybe that's not true. But then what more my Bible was like, it's quite true actually. But so it's quite sound on many things. There's been a few things where I've been like, yeah, uh, but it's quite solid to be fair. I'm not sure what other churches are like because I've never really been. Yeah, exactly. You just need to go and just be around different Christians and find the ones where where you're comfortable be around. And you just got to remember, like, no one's perfect, right? Everyone's a human being. Everyone's being going through the same kind of the sanctification step that you're going through. That's what it is until death, right? Sanctification. So yeah, we've all got our problems, right? We're all fallen human beings. It's a thing to remember. So this generates a typed buffer ID, so we can rather than having a U32, which is a bindless descriptor index, we basically just have a lovely wrapped structure type for it. So it's sort of no matching overloaded function found. And then they're saying the swizzle thingy is too long. So I think we don't go down through enough layers. We need more layers, I think. But then again, it's this silly GLSL compiler in it. So like, does it obey what C does? The answer is probably not. Yeah, so I think this will mean... Oh, yeah. So there's these things as well. Oh, wait a minute. That's in shader, isn't it? Yes, that'll do this. Oh, yes, you can't do that. So it's got to do a V0. Oh, yeah, I see now. Oh, these things are so annoying. Man, GLSL sucks. Why do we live with this silly thing? It all sucks. Soon we won't be here anymore, we'll be fine anyway. This stuff, man. So... even that, yeah. It's interesting. No worries, no worries. Alright, so what's going on? So you do this sort of voxel model keyframe thing, right? But that's actually V0 voxel model keyframe, right? So it goes into there and it should really, by the time it gets into this layer, completely like be V0 or whatever, right? So when it goes there and gets pasted on, why is it saying then no matching overloaded function called this? And then this one's too long. That's just a member, right? So def strut. I don't get it because it's just defining. Oh, it's in shader. I'm in the wrong file. That's why. It's the voxel shader, for crying out loud. Right, we're getting there. So where's this complaint about 66? Okay, so it was these guys that I saw. This ain't too bad. We can handle this one quite easy. So I just got to literally write the name v0 in there, and if we change the file version, we just got to up it, right? I didn't want to have to change it across the whole code base, that's why I've defined them. But if it's only in like literally one place or 3 places in one area, then I'm completely fine with that. So we'll live with that. It's all right. If not, we could put it in a macro and do that. But you know, we could do it actually. Where's the macro? So it's like buffer. Julius OID. Yeah, easy. So we could just do something like this. Come on. GP, sorry, shader. That ought to be good enough, and that should mean we don't have to put the V0 there anymore. Right, this is better. Cool. Right, we're getting super close. So we need to include the C file as part of the build script. So that would be Vox Builder, the compilation. Voxel C. Yeah, so where do we do this? Yeah, so the IO files it wants is voxel.io. Right, what are you complaining about now? Overflowed. Oh, so now we're just gonna make the voxel builder pass. So we could just hop into a debugging session here and see what the issue is. So we could hop into our debugger. That should ought to be good enough. Just run that one there. And we've got absolutely nothing. So that's probably because it's doing it from the wrong directory these days. No, that should be fine. So build cache debug right there. So box. Yeah, it should be alright. Why can't I just like, can I F11 that? Here we go, we're going through. Right, so where do we get up to? Okay, pause. Exit error, can I put a breakpoint on there maybe? Seem alright? There we go, beautiful. So we got some kind of overflow for some reason. Oh. Do we not do a break anymore or something dumb like that? No? The compiler should error if it comes across that. So 1, 2, 3. Oh, for crying out loud. I see what we're doing. Maybe. No, because it should. Oh, no, that's right. It reads 1 word and then pops it back. And yeah, so I think maybe I've changed some of this where I've not done the same amount of reads or something. So let's git diff this. What is it? It's the code voxel, sorry, apps, I think it is. Vox builder. Right. So I reckon there's some sort of read function that we was calling and are not now. Maybe. just in case. Right, can't see it there. Right, so let's look for some other read ops. So read, so deleted 3, but we put the 3 back. So yeah, it seems sufficient. Unless that set function, unless this set here is like calling this multiple times because it's in a macro or something. Probably what's going on. Let's have a look. So that is once. It's so many macros, right? Oh no, it is 3 times, you see? So it's that repeated 3 times, yeah. Right. That's what it is. So we'll just call it dims. Read once. And that's the issue. Cute. Let's keep going. So this one is overflowed again. That's probably because we've not saved Voxel build timestamp. That should rebuild the amazing. So that's rebuilt. Binary. And now it's crashing. Right, let's keep going. Right, so we've not allocated the voxel system in the. We haven't initialized the hash table either, so let's sort that out. So we need to init the voxel system, voxel cache. Yeah, do I call frame init? I've not sorted that out yet, I don't think. Yeah, I wonder if we called frame init. Yeah, I've recalled that. We've not called this function yet in the game. That's a good reminder. Let me just plop that down quickly. So game C logic tick. Let's just plop that in there. All right. I'm glad we found that problem. But yeah, so we want to say, right, we only really need like a model, probably not even a model. Let's just do one. Keyframes, let's just do 256. Nodes, a node 256 times 1,000. Chunks, that's not even a thing anymore. We should get rid of that. All right. Oh, I'm in the wrong place. This is the game. Whoopsie. Vox build. Let's pop that in there. Now we need to allocate the hash table. So hash only table. Init. So that would be G model keyframe index from hash. The allocator would be the static allocator. So we've got a thing called like. No, why do we. Yeah, we just got a thing called allocator. Yeah, why are we doing these? We're doing with virtual memory, yeah. Anyway. So we've got ASAN support as well if we want to track any major issues. Just turn ASAN on and use malloc or something. But yes, the capacity is 256. that'll automatically round up to nearest power of 2 and all that. So the hash function will be core fmv hash 64. Ought to be good enough. Wait. Why do we need a hash function in the hash only hash table? And there's no hashing going on anymore. Yeah, this is something new I've made where basically quite a lot of the time I don't really need a key. I just want a pre-computed hash to be the key. So yeah, I think this is a whole load of nothing. It is. Excellent. So I can just get rid of that. Nice. Happy about that. Right, says the hash only hash table. Not really tested this out yet, but I've seen it happen so many times now in my code base. I'm just making one. Right, so that's now initialized. Let's see how it goes. Come on. Right, got some more problems apparently. Oh wait. We need to get it to rebuild. Yeah, why does it run the voxels? I think this is part of the problem. It's trying to run. No, I did rebuild the thing here. Where did it rebuild the exe though? I can't see the exe being built. Oh, it's here, link. Why did it fail the link? Permission denied. So it was trying to run it. Like run the exe whilst trying to compile it. So let's look in the build script. I could have. You see, part of the issue is you've got where is it? So the Vox files. Yeah, it tries to build all the Vox files. I had to make it so the input dependency was the build timestamp, but then if the timestamp file changes, then rebuild, and yes, let's put a dependency on that rather than the executable. They both fire at the same time. Yeah, I need a better system. This is the reason why it's not working. I'll solve it off stream. It's a bit fiddly. Yeah, it's not even rebuilding the program anymore. You know, let's make it rebuild absolutely everything. It's gonna be a pain. But whilst we're developing, we've got to have it working. We'll just sort that out. There you go. Cool, so now it's rebuilt the new program and actually tries to run it. Nice. Right, so here it complains. So stack trace for some reason as well doesn't work. Out of memory. Right, why did that happen? Too much bumping. So the static allocator is not enough. No biggie, just make number go up. Then the program will be happy. So 8 megabytes ain't enough. So I don't know. Is 64 enough? This could ideally be probably nothing. Similar problem maybe. No ways you need that many. 1,000 nodes. Do you need 1,000 nodes? Wait, what's the other thing? Oh yeah, okay, right, okay. Is that too many? Can I do like 256? Will that help me? Nope. Oh, or it bumps into a different problem. Right, it's trying to allocate this silly block chunk pool thing. Yeah, I want to delete that. It's an old. Effectively, we want to have a lower resolution version of the map where it does it in blocks, which is a 16 by 16 by 16, and that's what the player's going to be standing on as a block. You can think of it from a 2D standpoint like a tile, right? But yeah, that was a separate data structure, and I think I'm just going to actually like make it all use the same data structure. Now the voxel map, sorry, the voxel one that we use for the voxel map and the voxel model, just all use the same one. It'll be really cool. And that way it should be able to be rendered on GPU as well and visualized for debugging purposes. Be pretty nice. Oh, so apparently we're doing some what's this complaint about? Updated why is this not wanting to work? So something's not initialized, that's for sure, but also why is the assert not going on? So custom stack trace. Oh, the frame allocator needs to be something. Right, let's make it a megabyte. That's the reason why half this stuff ain't working. So there's that goop though. Event thread. What? Why is it crazy? Did we not compile with like the correct? So log system. Log. Oh, the log is not initialized. Yeah, log is not initialized, so it doesn't actually do anything anymore. So yeah, that's the thing. So yeah, that's a problem. So yeah, I changed the log system a bit. It's now better. Just the issue is it should print it instead. Right there. Sort that out. Because otherwise, like effectively the current working directory will be in the wrong place and it will like pollute the project folder with these log files and stuff. So I changed it up a bit. So basically when we do a call log, we just need to print. So if it's not initialized, just print it. So it'll be a v printf. So it's going to standard out format the variable args, and that should be sufficient. I think we could do some extra bells and whistles, I reckon. We could do the file online as well. Maybe. Cool, let's see how that looks. I don't see what I'm supposed to be seeing. Does this not happen? No. No. Right, tell me. It's apparently it's a valid file. It hasn't initialized the log system. Right, that's not a good check, values check on basically, because the log that's -1 is invalid but initialized to 0, so problem. We should probably be looking at more of like, how many tags have you got? So on a log init, not really. Like, maybe we can have a disabled log level. If you do your the trace means absolutely everything. That's kind of at 0. Whereas, yeah, we can maybe invert it the other way around so it's off at 0 and do we do like less thans or anything like that somewhere around here? Do we need less thans or anything like that? Greater thans? Yeah, we do a greater, which is here, yeah. So if we do it a less than, and then we switch it the other way around, and we can make, so let's invert this the other way around, and then we can make level could be off basically, disabled. So that's no logging. So default initialized to disabled. If your log level is disabled, then it doesn't log out to a file. So it just logs out standard out. Now, what else uses this log level thingy? Let's try this. Right, that's improved now. Actually, get the logs coming out. So, talks about there being like a message or something. What's going on with that one? So, message. So the assert does a log, failed message. Right, let's see how that gets there then. So alright, then it does this thing again, doesn't it? And then does the message. Right, we shouldn't do the prefix. Prefix is not a good idea. Okay. Anywho. Right, so range star must be a multiple of 5 as it is aligned to a cache line. So what is the start index then? Yeah, then the stack trace is all goop. That's probably because we have an initialized B stack trace. I think we've got to do that. So B stack trace in it. Just a single header library, you can find it online. It's pretty good. Does a stack trace and stuff all for you. So I think it's in game.c, B stack. Come on. Alright, okay. B underscore stack trace. So game. Right, it's just a D in it. There's no in it somewhere, is there? Right, there's no initialize anywhere. Yes. Right, so anything else that's not been handled? Let's see, compared to the game, what's different. So the game will initialize the log system, which we don't care about. That's fine. Does a TLS? Cool, cool, cool. It does initialize the operating system. Maybe that's something, but probably not, because it's all the whole event thread and all of that. Nah, I think it's alright. Oh. No. Wait, there's a segfault handler. There is that. Do. That could go in pre-initialize, maybe. Yeah, that's interesting. Maybe we can do that. Where's pre in it? This would be useful. But yes, still though, this didn't. The stack trace is still a bunch of goop. For some reason. Wonder why that is. So we do one of these. Let's analyze what goes on here. Right, so we might not have on some certain flags. So it's just gonna So it does an error. Interesting. Wonder if there's any different flags in the build system. Shouldn't be. But maybe there is. Just look at Vox Builder. So this one builds. So it does a bunch of this stuff. So where's the game? This looks very game-like. The DLL. So okay, nothing much there. The EXE is a separate thing though. The game EXE or whatever it is. There it is. But yeah, similar sorts of stuff really. Don't think there's any special command line args which are not shared. In sort of build in it, I think there's a set of shared flags thrown somewhere. So everything should be getting in debug. It should be getting all this sort of stuff, right? Why is he getting this sort of event thread main? Like that's a string that's sitting somewhere. We're not even running that. I guess it's a function, but we haven't run it. It's all building the debug variant as well. What else could it be? Yeah, so if we take a look here, this is the one for the game, the crash handler as it's called. We go to the builder. It's the same thing, so for one prints and one uses this thing. Same thing. Same thing. So why? Stack is not corrupted, I don't think. We could just fix the problem rather than trying to hunt down why the stack trace don't work. Let's just do that. So if we run it, so this is an overflow, am I right? Yeah, so it's okay. So it's going to point a difference when the keyframe is not allocated as part of the keyframes array. So we've got to do that. I was hoping to get out of, yeah, why does it need an index into the keyframes? What is it doing? Where is it? Oh, this is a different place. Hang on a minute. Right. Yeah, here we go. So sometimes it hits it, sometimes it doesn't. But yeah, so why does it need... Oh, because it marks them as needing to be updated. Right, I see. Um, so it marks the keyframes as changed so it can upload them to the GPU. So we need to... Alright, no biggie. Right. So we need a model in the global. Call it model. So when we start, we'll just make a if you can't copy paste. Right, got me some ideas. So these can't be a linear array anymore. It can be a pointer. Sorry, it can't be a linear, it can't be an inlined array in the structure. It's got to be a pointer to another place in memory. So we'll call it global and model. So we need to instantiate those at boot here, just so we can have arrays of keyframes basically. So I think it's something like this. How many keyframes do you want? 256. And we want to throw that into G global model and then G model. I think that's an ID. Okay. So hang on a sec. So that will be voxel model get. So you can now basically just model keyframes. So that'll be something like voxel model keyframe get. Okay, that's in a good place. Okay, right. Then now, just got to double check we don't do like a deref or take a size of or something like that. We're doing an array count. Oh boy. Same thing. There we go. Right, so that should hopefully fix the issue. Right, so the next issue is, and we saw this one earlier, apparently it's not been able to allocate any, like, oh no. Mark updated. Does that matter? We took this away. The nodes. No, this doesn't matter anymore. Words per cache line. So we used to have fixed sized the number of bits per voxel, but now we've got it configurable basically. And so voxel updated. Yeah, these guys here. So the start index can't be aligned to this. This shouldn't be used. Well, yeah. We shouldn't have the assert at least. Okay, so how does that work? Oh man, these are really bad. There's a keyframes complaint as well, so get rid of that too. Expected node to be a leaf. That's a weird problem. Didn't get it when we generated the map. So that's just doing a bunch of sets, I imagine. Oh, excuse me. Why is the node index 0? Have we got like barely any dimensions on that? Is there no dims? So it's descending down the tree basically trying to find the leaf node. So the dims of this are something that we can't see. Oh, amazing. We should have done the initialize here, right? Before. So dims are 4. So that means that is the smallest size. So it should be the leaf. The root is the leaf. Right, the root node is the leaf. That's an interesting set of that's an interesting thing I've not handled yet. So right. So we'll go through here. And it only really marks the child as being a leaf, I think. Is that right? No, it marks itself as being a leaf. But the bit set is interesting. It doesn't want it, I think, the root node. Alright, by saying that doesn't. Right, let's just follow it through so we can just find out quicker. So yeah, allocates your nodes, but they're not one-ed. So it doesn't go into yeah, this one will pass fine, I think. Yeah, it's probably one of the future ones where it fails. But yeah, I see the problem. So when he gets it for a right, we want, whenever we allocate the child nodes, it kind of ones the data, ones the cold data. So like rather than zeroing, right, puts ones. And that's the initialization. So we want to actually do that when you allocate this, but only when it's not been copied but initialized for the first time. Oh, that's interesting. Wait. Why don't we want it here? Yeah, so then why are we doing it? Dual shift right. Okay, then we did the individual element. I see. Right. So when we shifted right to insert, we won the element that we're trying to insert into. Right, so this one's complaining about what now? So, trying to do what now? Oh, that's a big old number there. Yes, the parent is U32. Okay, so this is... Just want to ignore that on the first time around. Well, you could make the parent equal to node index, and that way it just does itself. Or you put an if statement around it. Be sufficient there. It works. We've built some voxel files apparently. Probably got other problems, but that's good. Right, so why else doesn't it run now? So fixed line heap dealloc. Frame init. Oh yeah, we ain't called frame initialize yet. Why has it got a dealloc in the frame init? Seems incredibly weird. Oh, okay. Right, what? Oh yeah, right. So it removes the old data. Right, I see now. Range 0 to 0 has been freed twice or is invalid. Who's put in 0, 0 on the... on the queue? Which one is that? 579? Apparently for the node. So the ones that set the node. Like, who marked 0, 0 for deletion? Right, we can always track that. So it's the first one, I think. No. Anyways, we'll just find it quick. So luckily we need these sort of conditional ones, right? So you just say range dot end equals 0. Let's have a little look. Bum, bum, bum. Oh no, I want to kick off the build script. Let's go. Not sure what's going on here. I think I busted it somehow. All right, we hit the same issue. Yeah, the range is really 0, 0, but how did it get on there? Maybe this is like the value which gets poked on at the beginning to say like this is a new frame. But I thought that was a special thing. Yeah, it's count, isn't it? But that looks like a little problem, doesn't it? Not using the right index. Hello. Oh, hey, welcome, guys. Thank you for the raid, sir. Welcome, guys. How you doing? We're currently just trying to get the code base booted up. We're running, what are we working on? We're working on the new Voxel file format. So we've got this sort of like procedurally generated map, just a sine wave. It's a 4x4x4 sparse voxel tree, so you've probably seen these things around. And we're just trying to get the file format to be used in this tree format and just loading it up from disk basically. Well, sorry, we're going to save and add to disk, and we're just trying to get the game booted up again so we can actually write the loading code for it. Yeah, I'm using Rad Debugger. It's pretty right. Does the job. Don't have to use Visual Studio anymore. One of the great things about using Windows. But yeah, how was the last stream, Ryan? Thank you for the raid, sir. Yeah, so here we've got a sort of rollback queue, and I think we used the wrong index, right? It's this sort of classic problem. Where we're going to. So I think it needs to be plus index. We better be doing that properly in the other places. Yeah, because they just allocated 1 in the past. I think that's why. Copy paste code. Alright, so it should be good. Should be sufficient. Right, so we've got another custom deallocation. So it has been freed twice or is invalid. There is no memory at this range allocated at the moment. So frame initialize. Yeah, which one of these is failing? So B79. So yeah, it's another one of these nodes. But yeah, we're just popping it in the debugger here again. And if it wants to run the program and not freeze, yeah, it does that sometimes. Oh, okay, I was just being impatient. What have I done? Now I gotta get the right executable. Which one is it? The one that was using more memory or higher CPU. Right, the one which got the error. Thank you very much. Hopefully the stream's still alright. We're good. Back into business. So yeah, let's run in the debugger again. Oh, have we got, you know what's going on? I wonder why it's been a bit funny. I've got my build system in the background running, and it's like picking up on changes and then trying to boot the game again. So when the debugger runs my build script, it's sort of like fighting with the other thing, right? So, anywho, we can now look at the, you know what, I guess we could print out, yeah, it would be nice if we could, how many allocations are there? Quite a lot of allocations. It's too much to sift through manually. But yeah, we could probably put a watch point here. So we're looking at probably ending in 1344 maybe. Let's just put one down like that. Well, let's do the start. So it's 1280. Okay. So we hit in here and that looks like not sure what's going in here now. It's had a lot of allocations as well. It has been going for a bit. It's just the, yeah, it's a bit weird. Right, it's just a bug there. Sift through that again. So it happens again a second time. So, and then I guess it, yeah, great. So we just found a nice way to debug it. So is it upping the head index? That's probably the issue, isn't it? Right, it's not moving this number here. It's my first guess. Come on. Work with me. Right, let's throw in the watch window. 8. So if we look at that number the next time, F5 it, pop back up, it's still 8. Again, another one of those issues. So that will be, so head, ooh, outside the for loop. Or the while loop, rather. Wait, do we need to move off? We need to move off it anyway, yeah, so we need both of them. Okay. There's no continues in there, so that should be sufficient. And off we go. No. Right, I'm not sure what's going on here now. What have I done? Yeah, I had 2 build systems running. And yeah, it doesn't stop now. Let's just close that. Okay, much better. Right, so this is the first time it hits. And the head is 8. So let's just walk it through, really. Let's do a step out. Hang on. Sorry, I've been silly. That was really, really stupid of me. I'm tired. And it's up the head index. That's the variable I'm looking for. Right, that makes sense. Yeah. And then it's equal to head plus 1. All right. Boom, we're back in business. Look at that. Right, I'm just going to be right back. I'm just going to sort my son out. I'll be back. But here we go. It's running. Be any questions, feel free to ask away. I'll answer them when I get back. I'm back. Welcome back, everyone. Okay. Where was we? We're all good. But yeah, so now we've got these like files which are being generated. So it takes in as input, right? Assets, voxel models, box.vox. So these are obviously built in Magic of Voxel, and the idea is these will be hot reloadable assets that this Vox builder thing picks up, and then it like, you know, the build system, just a little build system are thrown together. It gets all those voxel models and it essentially throws them in build package. So it's packaged, something to package up basically, assets, voxel models, and they're here in this sort of vmod file. The vmod file is a voxel model and it's just a tree. So if we go to v voxel model enc, this is the sort of encoder file for it. It's just a little custom C like data description language that supports packing and ranges and stuff like this and versioning. And it also does stuff for like, you know, you can use it for like files, GPU and networking. That's the plan. Or it currently works on files and GPU, so it should just work for networking quite well. But yes, it's just a tree of 4x4x4 nodes, right? That sort of thing. So we should. So the idea is we'll be using this for the models that get authored and for also the map procedurally generated. Now the map might be quite big, so we want to stream it to disk and back from disk. And this file will be able to generate at runtime during while the game's running. And cache out the map to disk. Load it back in again, which would be pretty cool. So, yeah, I wanted to fix one thing actually before we pick up. But so this, oh, for crying out loud, I think I press F4 and sometimes I think it picks up as Alt F4, and it obviously causes a whole bunch of problems. But what did I want? I wanted the voxel. What is going on? Here we go. Right. Yeah, so, we've got a few layers, right? So we've got this outer layer here, we've got more of an inner layer, and then this super inner layer here is not following the 4x4x4. It's doing kind of 16 by 16 by 16, so it's doing the layer down from what it should be. So we just quickly pop into the shader which does that, or the shared shader code, voxel shader.h. So we've got some sort of iteration where we keep basically going up and down the tree. So when we finally get a hit and it's, oh, hang on a minute. Yeah, when we finally get a hit, what is this? This should be below here. That's a problem. When we finally get a hit and it is a leaf node. Wait. Oh, is oh, no, it's fine. It does go here. This is a leaf node here because this is the non-leaf node check and it does an early continue. Anywho, what are we doing here? So yeah, go down the tree up to the node depth. This will be the current node depth it ends at. So we need to do a +1. And we could probably get rid of this because this is what renders that horrible 1x1, which we obviously is, maybe it's not useful. Sorry, maybe it is useful. We'll leave it there. So it was missing an extra layer, basically, off by 1 error. So now that should have hot reloaded, but it hasn't. What's up with my hot reloading sometimes? Oh, it's not running anymore. Yeah, I'm not sure what's going on there. Yeah, I think the build system stopped running. Anywho, so we pop on the hit debug, have a little look. There we go. So we see we've got another smaller. Oh, no. Sorry, I spoke too soon. We still don't see it. And it did recompile the voxel shaders, right? They're right there. Weird. Node depth +1. If I comment out of that, it doesn't do the little 1x1 anymore. Okay, cool. So we are seeing it change. So if we get rid of that, let's hover here and save. It's not done anything. Very strange. I wonder then. So if I comment that out, does the rest of it stop rendering? Yeah, it does. So this is what's causing it to be rendered. So we'll go up this sort of node stack thing. So the first one which goes on, yes, as we traverse, is this going in? Yeah. No, this is traversing up. You're traversing out of the level. Yeah, upper level is the way of saying it. This is going down a level, as you'll put on. So we should reach Yeah, so I think, yeah, so actually, we're probably we're probably supposed to manually do another level. Or just call it node. Rather than child, just call it node. Let's try that out. There we go, there's our 4x4. Ta-da! Right, that's good. What about the yeah, the miss is already working, I think. Cool. Right, that'll be helpful. Right, what else could we look into? Yeah, we should probably restore the build system. We had a bit of a bug, so I had to, like, effectively got a problem, right? If we change a piece of code in the core libraries, like, you know, core.c or os.c, the voxel builder depends on those, but when the voxel builder changes, these are all of the models, right, that we're trying to rebuild, and we don't have the dependency on the exe, because when the exe changes, which will be a lot every time we program, basically, it'll rebuild every asset. So I'm trying to find a way to sort of stop it doing that. And my current solution is not the best. We need to sort that out. Let's just undo that problem so it doesn't rebuild everything all the time. But yeah. Okay. Amazing. Right, so all that's left to do is we just need to write the loading code to test out whether this works or not. But unfortunately, I can't really finish that off today because it's getting quite late now. But yeah, usually there is a stream tomorrow, but I got to cancel it, unfortunately, because basically my wife is in hospital, and usually she looks after our son, but that's currently not the case, so I don't really have tomorrow available anymore. But yeah, so I've been like to and fro up the hospital, like today, yesterday, and stuff like that. So the baby's close, basically. There'll be a baby soon. It's coming. The due date is like the 6th of September, but this one might come early, maybe. We'll see. But yeah, so stream schedule is usually Tuesdays, Thursdays, and Sundays at 7:30 p.m. GMT +1. There's a YouTube channel where they do go up to watch later as well. And there's a Discord channel we can come and chat in the meantime and talk about programming. Oh, you got amazing kit. That's awesome. Now I remember you told me a while ago. You told me that your wife was pregnant a long time ago. I think now I'm gonna recall it, but I didn't realize it was. Yeah, I forgot basically. That's cool. That's awesome. Is it your first one? Remind me. And there's also a way to support the channel and get access to the code to run on your own local machine as well. And thank you for everyone who's supporting the channel. You know, it's a Ko-Fi, support via Ko-Fi. All the instructions and terms are on the Ko-Fi page. But yeah, thank you everyone who's supporting the channel. But yeah, there's also on the YouTube channel, there's also a video going over the game that we're building. We're just trying to get the voxel models in a good place. And then we'll move on to basically generating a little map, generating generating a map, and yeah, maybe some content for the map as well, but then get the entities in there and just start testing gameplay really. Cool. So, Kev, have you got any names? Got any? Have you worked out a name yet? I still haven't worked out a name for my son. I've got some, right? But the problem is every time I tell my wife a name, right? Like basically, I do the wrong thing, right? I should save my best names till last, right? Get all the bad names out first, but I keep giving my best names first. So that's the way it is. So I believe. Oh, so you've got a female, right? Is that correct? You've got a female baby. Nice. I forget your wife wants to spell it. Cool. Amazing. So you guys are quite prepared then. Yeah, that's cool. Exciting times. Always pictured a boy in my thoughts, but this should be interesting. Yeah. Yeah, good fun. Yeah. Yeah, I just gotta, my son is at 3 now, so we've got to make sure we just gotta be careful. Just teach him to be careful and delicate with this new baby. He's gonna be excited because he sees other babies and he points to them and he says their names. But yeah, I'm quite rough with my boy. I tickle him, he tickles me back, and we have do that sort of play fighting stuff. So yeah, got to teach him to be calm now. Yeah, having another boy. So yeah, good fun. Yeah. So I'll be in a little Moses basket or whatever. Maybe we'll get a new bed, but in our room. My boy's got his own room, so he'll be in there for a while. But yeah. But yeah, so no stream tomorrow, guys. Unfortunately, that one's going to be cancelled. But hopefully, there'll be one Sunday. We'll see how my wife is. It's all just a bit up in the air at the moment. But yeah, I'll see if I get some time off stream as well to do a little bit more. Maybe I'll get the loading code finished and we can move on to something else. Maybe do like the procedural map generation, make something a bit better. But yeah, anywho, yeah, off stream I should probably get a voxel model made as well, like a character with at least some sort of movement animation. That would be cool, right? But yeah. Hmm. Anyway, have a good night, guys. God bless you all, and see you all later. Bye.